Hello everyone. GM, good morning, good evening, good afternoon, good night, good down, whatever the time that you have there. Welcome everyone for lesson 10/2, lesson 11. We're literally going to pick everything that we did in lesson 10, the challenge explanation now, and continue today. So nothing new on the lesson plan itself, on what we're doing. We are going to keep going with this challenge here, okay, until we finish studying the planned content for today about divisions, about the patterns, about this big int in JavaScript, those patterns that we are using. We're going to cover all of this explanation while coding the challenge, okay? So for today's lesson, you need to have TokenSale.sol and TokenSale.ts from what we did yesterday, okay, and start coding along. Like yesterday, I'm not going to explain much by myself. We're going to complete this challenge together, so I count on your contribution, on your participation today. And if you are not coding along, if you prefer to wait for the recording to code along, it's no problem. Just participate with me. Make sure you are understanding it now, because whenever you're asking questions asynchronously, it takes much more time for me to answer, of course. So make sure you're paying attention and following, so that you can understand the flow of thought here. Okay. So where we stopped last lesson 10, what was the last thing we did? Last thing we coded, let's see if you remember.
We finish the constructor.
Constructor. And what else? Dante, you raised your hand. We did the constructor, that is correctly, but we did something else here within these lines and within this line, right?
You use the fake accounts where you are having lines 14 and 15 that this is wrong. So I think the next steps would be then to pull the actual contract instance, which I assume, have to also put as a part of the deployed contract.
Wonderful. Yes, because when using a wrong address here, as line 14 and 15, using a wrong address, when I try to use it as a valid payment token, it fails, because this address is not a smart contract, doesn't have the total supply function, so it gives me this error. Okay, so the test is not passing. Okay, so this was the last thing we did. Thank you a lot, Ivan, for participating, for recalling this. I want to know if it's everyone in the same page. Yes, Arda, you have a question?
Yes. So although we initial question which I'm having, which I guess you're having too, although we inherited the ERC20 contract in our token, this token contract.read doesn't see a total supply function. Can you explain why that is?
Because when deploying that smart contract, we are using a wrong address. Okay.
So once we deploy correctly, it's going to understand that it's a ERC decent contract.
Yeah.
No. Okay.
Well, and it'll be able to read the supply. Is that what's going on?
Yeah, for now, it's a wrong contract. Anything that we call on it, like name, total supply, anything that we call is going to fail. Let me see if I did that correctly. So for example, this is a wrong address too. So if I try to read total supply, let me debug this test. So I'm passing in the constructor the 0 address as the address of that token. I had an error for some reason. What's happening? Debug. Yeah, sometimes the tests, they don't attach for some reason. Address 0, missing some, it was supposed to be 46, 42. We Google it really quickly. EVM 0 address. Because I'm missing. Supposed to be 2 here. 42. With the 0x. Okay, that was my bad. Let me debug again. So I'm using another wrong address here just to exemplify what is happening. So I can store this wrong address inside this smart contract. Token contract address is the address 0. I can. Nothing stops me. Arda, your question is correct. Even though we are treating it as a payment token, it is not. But then when I continue, I have this problem. The contract function return this value, it is not able to respond to this call. Photo supply. I could try with a name, symbol. I could do many calls here and they would all fail, of course. Okay. So instead of using those wrong addresses here, it doesn't matter if the 0 address or another address, what I could do to have a correct contract being passed for the smart contract?
You could also create it.
Could also create it before. Yes. Let's do like this. Const payment token contract equals to await VM deploy contract. And what's the name of the contract for the token again?
My token, I think.
We named it my token. Does it need any parameter? It doesn't need anything because I'm hard coding the name and the symbol. So payment tokens like this. And I can use the payment token contract. Dot address. So this is not wrong anymore. Okay. Questions about this? So that if I run this test now, it should deploy that token. Then I had this other error, but I'm going to fix that in a while. Yes, then a question.
Yeah, so just to confirm, or like to recap, we went back and we added the payment token contract so that we could bring in the address from my token, correct?
Yes, in this situation, I deployed a new token contract, deployed a new instance of it to a new address, and now I can pass it to the in the deploy contract fixture. I can pass this payment token contract. I can pass it as a parameter for the constructor function of the token sale. You see?
Yes, I see it.
And
So
then we
now
do
when
the same thing with the NFT, right?
yeah. What was the name we gave? My NFT. Okay. Very pretty. My NFT. So
When we
NFT.
add those, what is that called? We're calling that contract. Is that what it's called?
So for now, we are just storing the address of this contract inside the other smart contract. Just storing. We're not even calling. We're going to call in the future. but we're just storing it there. Okay. Yes, Johnson.
Can you just paste this in the chat so that will help me to paste into the TypeScript?
Okay. Yes.
Yeah.
We're going to,
because I am very slow typing. I cannot I can't do this when you are talking, skipping the cursor and typing. I couldn't follow.
No, yes, I was suggesting that if you need more time, do pay attention.
Yeah.
You don't need to type fast because it's stressing, Do pay attention, understand what I'm doing, and then you can watch the recording and type together. So you ask the questions now and type later. Because I need you to type this because for some reasons, the way your brain works, when we type things, when we write things with pen and paper and all, we increase a lot of the chance to remember these things. For some reason, I'm not a specialist.
Okay.
I just know that because like the what's called in English when we teach people, there is a discipline about that. Pedagogics, I guess. Pedagogy. Yeah, pedagogy. The pedagogy instructions tell us that every time that we do exercises on things, on things that we are learning, increases by some amount of percent. I don't remember how much. And all of those studies, they are very outdated too, like 40, 50, 60 years ago, but they hold still an amount of truth of it. Okay. Yvonne, you wanted to ask something?
I had a conceptual question. It seems to me that when we are doing the unit test, we are creating a whole our environment so we can test it completely. But when we go eventually to the kind of production, I mean, some of the things like we are creating now, my token and my NFT, some of them potentially will exist already in life. So it is then our responsibility to kind of keep track of the proper addresses and things and kind of plan properly the launch of the new token sale.
Yes. When doing things in productions, usually you have a script to do this, and then you use it as a parameter. We're going to use a project next week with called Scaffold ETH that keep tracks of those deployments when you make a deployment, so it stores the address, it doesn't deploy again. So there are some structures in place for us to keep track of these things.
Okay.
In this situation, I'm comparing a big number with a number, but this big number that is storing the total supply should be greater or equal to 0 n, but it's not going to work, a number or data. How much did I put? Let me see in my token. 10 decimals. So to equal, let's change to equal here. And let's use this function from VM that is pass ether. Actually, let's make a little adjustment to our smart contract. Okay. Let's remove this initial mint here on line 11. Okay. I could check it, but just need to import pass ether now that we're going to do later. Let's not get ahead of ourselves. Let's go slowly. Just remove this initial mint from the smart contract, compile the smart contract, and then I guarantee that the initial value of the total supply is going to be 0, so this test is going to pass very quickly. Okay, so I know that it's there. It is a valid ERC20 payment token because the total supply is returning 0. This is not a perfect test. I know. I would need to check a lot of things. I could expect this call not to reverse. There are many better ways to do this test. But for today, just to explaining what we're trying to do, it makes sense. Okay. Arda?
I'm still having a problem reading the token contract total supply.
Did you compile your smart contract?
Yes.
And did you add it here into the fixture?
Let's see. Token sale contract, NFT contract. Yes.
Then you can put a breakpoint to and see what is coming on the contract address to see if the contract that you deployed.
Okay, let me try.
Okay. Nathan asks if there is a way to verify directly the contract type, like ERC20, ERC721, when getting the address. So there are some techniques you can do to register that your contract complies to that interface now, but there is no type check, native type check on chain. Okay. So you might read a contract as ERC20, but it's not an ERC20. This whole interface things is a big mess. A lot of people lost money with this. For example, sent a token to a contract, imagining that it would support a token, but it doesn't. So you don't have any way to check, and then there is money losses at that smart contract. So this is a big issue, okay? But there are tools, there are CLI tools. For example, lesson 24, we're going to use a tool called Slither, where one of the checks is to check conformity for an ERC. Okay, so we can use CLIs for running those. But there is no way to test a type check on smart contracts on the fly just by getting the addresses, okay? Programmatically like this, it's more difficult. Okay, Arda, you still have your hand raised? No worries, no
Sorry.
worries. Okay. And just as of curiosity, people, we could test all of those calls like this. Expect, await, expect, token contract dot name dot read dot name not to be averted, rejected, something like this. So there are some methods that you can ask a call and expect it not to be rejected, and also you don't care with the name and all. I'm not sure if the syntax is correct here. You see, yeah, it's corrected. So you can test some things like this. I expect this call not to be rejected. I expect this other call not to be rejected. I expect those signatures should be there, you know? So I don't care about the total supply itself. I could have done that actually. It would be much easier. Okay. But this concludes the check. Here I could do the same thing for the 721 for checking if I do have a NFT collection there. NFTs, I have owners of tokens. I have the URI of that token. There are special methods that I could test there. Okay. Yes, others. Forgetting those awaits is very, very common. Okay, any questions about the structure here before we advance for the payments part? This is the structure of that smart contract. One contract token sale is going to interface with all the contracts by address here, by interface. Okay. And later we're going to change this type from address to the interface itself to be even easier to work with them. Okay. So I don't need to import these. Take it out. I'm not going to use these for now. Second, for questions here, raise your hand if you want to stop the lesson now, if you're still catching up on something. If not, we're going to proceed for that payments part, okay? The ratio for giving ETH and the price for minting NFTs. Okay, I guess we can do those two today if we have time. I'm not going to complete all the tests, but those two might be very enlightening for most of those patterns that we need to do here. Okay, no questions. Let's move forward. When the user buys an ERC20 from the token contract, so it should charge the correct amount of ETH, it should give a correct amount of tokens. Let's code these functions. Let's code a function here to do the purchase, to buy this token, buy ERC20, and then we're going to call it from those test scenarios, okay? Here, people, I could even do another fixture, okay? I could do something that is before each hook so that I call this hook before each of those tests functions and all, okay? For today, since we are low on time, I'm going to speed through this. I'm going to code everything inside the test scenarios itself, repeating my code, but consider that for the future, you can nest those tests and you can have a better structure with more fixtures. One fixture can call the order, you see, to properly coordinate what we're doing. So whenever I'm buying a token, I don't have that function yet in the smart contract. I should add it here, right? Laurent, this is just an example, okay? It's not super needed. It's just an example, but if you want to have it there. Okay, ideally you can find those by doing the dot, and then you can find like this from the things that you are typing, just to hit tab. But don't distress with every little detail. I want to ask your attention, all of your attention right now. Instead of copying code, I want to ask you questions. I need to implement a function in the token sale to purchase tokens, right? Function to purchase, to buy tokens. Buy tokens. How would you code this function? Asking for contributions and suggestions here for all of you. Let's focus on the function definition for now. How would you do the function definition?
Takes the parameter quantity.
Okay, let's see. We have Dante with the hand raised. We have some suggestions in the chat. Let's start with you, Dante.
Well, if we're gonna buy, we need to make it public, right? So anyone can access it, and then I guess throw payable on it because
Payable.
we're moving money or moving, I guess, tokens.
Native tokens, yes. Nathan suggested that too. Marco suggested that too. Trust, you raised your hand. What are your suggestions?
Okay, I would say, first of all, we can create a buy token function, then we collect inputs from the user to know exact amount of tokens that they want to buy. Then the code should be external. Hello? Because we're not calling it within the function, it's going to be called from outside the function. So I'll say external. Then visibility, okay, then it should be table. Hello?
Yes, so public, external, both would work. Payable enables us to work with native tokens, correct? Ivan, you also suggested for us to take an amount in the parameters. So you int 256 amount, something like that.
I thought quantity you want to buy, not the amount you want to pay. I think it's more.
Okay, Javier also suggested the address of the buyer, something like this, Javier.
Yeah, as a parameter, but to check like the balance, maybe if the address has balance to purchase our token.
Okay, okay. So let's think on this. Let's start implementing this function here. So first thing to do, or maybe the to do, how to charge ETH from the buyer. Let's see if you remember that from week 1.
That's what we're gonna check.
I want a lot of people speaking in the chat and raising the hands to speak now. Nathan is adding a comment here in the chat.
We got to
Yes.
make the person that is gonna buy the ETH. If they're gonna buy the ETH, we got to make sure that they have what it takes, right?
Yes, yes, this is correct. The person should have, like, if I'm saying 1 ETH, I should have 10 ETH for that now. But do you all recall how the payable function would work from lesson 2, lesson 3? Don't recall correctly now. The person sending the transaction would already specify how much they want to pay, right?
We will have it like in message.value or something like that, is it?
Message.value, correct. And also we do have the address of the buyer already in the message.sender.
Oh, you're right.
So I have the quantity that I want to pass. I have the address of the person, and I don't even need to charge. The money is there already. Oh, I'll solve it with a single keyboard. Yes, this is how we handle native tokens. Unfortunately, for handling ERC20s and all, it is more difficult, but for handling native tokens, it is very easy. Okay, and here, if I'm buying from the smart contract, okay, so to do 1, determine how much to give of tokens to that person, and the to do 2, give the correct amount of tokens to that person. Okay. So those are the only 2 things I need to take care about. Arda?
So the buyer will be calling the buy tokens, right, from a certain address. Is it the general practice that whoever pays always gets the tokens, or is there another option where somebody pays for some other address to get the tokens?
It's possible. For example, in Uniswap and in DuoSwap, you can specify another receiver. You can code on that. It's not on the specifications. So a person would buy ERC20 tokens with ETH for a fixed ratio. So this is the current specifications. Not saying that they can buy for someone else. We could implement it like that, wouldn't be wrong. Okay. But here the default way would be the person buy for itself by sending ETH for the contract for the fixed ratio. Okay. Dante, you have a question about this too?
Yeah. So the process is going to be the buyer comes in with ETH, and they're gonna give us ETH, and they're gonna mint a token, right?
Yes. And this ETH is going to be stored inside the token sale, because later, if the person wants to burn the ERC20, they should receive that ETH that was stored. You see? So at some place, I should have a function called burn tokens. And we are going to do this later. So I need to have that ETH stored there. Okay, questions, Laurent?
Yes, can you re-explain why you remove from the input the quantity?
Because the person sending the transaction is already going to specify how much they want to send in this parameter, the MSG value. We just it like this. You win to 256. You win to 256 amount being paid equals to this. Okay. So if I have a you win 256 amount to be minted, how much is going to be?
The message dot value divided by 10, was it?
Let's see. The ratio R means that each
the
one
ratio.
ETH should buy R tokens. So if the ratio is 10, one ETH should buy 10 tokens, right?
Yeah.
So here, what would be the correct operation?
Multiply by the
Multiply.
ratio amount.
The amount being paid in ETH multiplied by the ratio that I have stored inside that smart contract. So this, Laurent, is why I don't need to pass the amount. It is going to be calculated by how much I have sent, okay?
And this message dot value, is there a link with gas fee or it's not related?
Not related to gas fee. This is related to the amount I'm passing for that function, as we saw in the lesson 3, I guess.
Okay.
Lesson 2 or 3. Okay. So let me compile this smart contract. I know I still have some things to do here, but let me compile and go back for the test just to make sure we know what to do here. I'm going to pick the token sale contract from the fixture. Okay. Let me do this test with the account, with the other account. Okay, I don't want to do this test with the deployer. I want to do this test with the other account. Okay. So I'm going to pick the token sale contract. I'm going to do a transaction. We did that with this script. Remember, transaction equals to await the token sale contract dot write dot buy tokens. And I do have some options here. I do have value, the amount that I want to pass. Okay. I can specify an amount here in my consts, for example, const test by ETH amount. Test by, let's just put test by whatever. And this is going to be, let's put it 1 ETH. Is this the correct way to specify 1 ETH? Let's see if you remember. No, right? I need to format Ether or parse Ether. So I'm going to import those two. Port from VM. Those two functions that we have used in the Monday's lesson. Format Ether to go from a string, to go from a big number to a string, and pass Ether I mistake those two all the time. You don't need to remember top of your head. You just hover your mouse, and then you're going to see that pass ether is going to come from a string to big number. So I'm going to pass ether, and I'm going to put 1. So here we are going to test buying tokens by sending 1 ether to the contract. Okay. This is the test by tokens. Put like this. Test by tokens. Okay, so the value that I'm going to pass for that function is going to be test by tokens. Okay. Also, I can specify the account. Okay, just so that we don't use the deployer all the time. It's going to be the account dot account. You do need to pick this account object all the time. This is going to send this transaction. Okay. This transaction might wait a while, might take a while to complete. Okay, I can debug this transaction later. And then after this transaction completes, I should have the correct amount of tokens. So I should have a token balance before that transaction, and I should have a token balance after that transaction, right? How to get my token balance before the transaction? How to get the token balance before the transaction? Do you know? Suggestions? Want to quickly apply this?
The balance of the address.
Okay, but in what object should I pick the balance? In the public client or in something else?
Public line.
Where? Sorry, I couldn't hear it well.
Do you have to get the balance from the actual my token contract?
From the actual my token contract, yes. And strategically, I have written it in the fixture so that I can just pick it here now. Payment token contract. And I can now wait the payment token contract read. What function should I read?
Total supply.
Yeah, for getting my balance of tokens in the payment token contract.
Is it balance of?
Balance of, perfect. Balance of, and I should pass the order account address. Okay, we did all of that on Monday. Okay, it was slow, it was maybe boring to do all of those scripts, but now we are using all of those lines of code again. So if you missed it on Monday's lesson, you might need it now. So we use it, I read to the, I even have those scripts here. So how I was reading the balance, the total supply, how I did the transaction, what is the balance. So we did all of those functions here in this ERC20 test, remember? Now I'm using them again here in this token sale. So this is why I pass homework. It's not because I want you to use free time now. I want you to remember these things. So we are going to pick the token balance before by picking the payment token contract and reading the balance of this account on it. And the balance after the buy transaction, it is just calling it again. So I'm going to have this transaction before, this transaction after. If you are testing this in public test nets it is very important to await for the confirmation. You would have the public client here, and you would have something like this: await public client, get a transaction receipt. Okay, we did that in the script. Whenever I finish a transaction, I have this wait for transaction receipt, not get. Sorry. I would have this wait for transaction receipt by passing the hash of the transaction here as the transaction that we sent before. So this is not that needed on unit tests. It would work without it, but whenever you are doing things in public test nets or things that have latency, it is important to wait for transactions before doing things, because it's not because you have sent a transaction that it is automatically included in the blockchain. It might take a little while. So I have this token balance before I buy. I have this token balance before I buy. I'm going to have a difference. So const difference equals to the token balance after minus the token balance before. Okay. And I expect the difference to be what?
Message.value.
Let's think on that. I'm sending 1 ETH for the contract to buy tokens, and the ratio is 10. Before I buy, I would have 0 tokens. After I buy, as we have coded here, it's not implemented yet, but we expect to have 1 ETH that I sent multiplied by the ratio that is 10. So I expect to have minted 10 tokens, right?
Well, shall we do it with the format ether or?
We can do both ways. We can even pick this that I have here, this test by tokens,
And
and
multiply by the
multiply
ratio.
it by the ratio. Okay. Marco, I did the after minus before because I know that it's going to increase. I don't want to have negative numbers here. But if you want, you can keep like that and check the negatives. It would work too. Okay. Lawrence, you still have your hand raised? I don't know if you want to ask another question or if you still have problems with your last question.
I raise my hand.
Okay. No worries. Yeah. Marco, yes, I type a lot of things, so it's good for us to understand something, and then I pause, I'm going to take a sip of water, answer some questions. So we have this slow progress by trenches. Okay, so and then we can review things, we can go back. I'm documenting everything as we are doing, so we have those to-dos. So it should follow like this. If I'm going too fast, please let me know too, okay? You can yell at me, you're going too fast, and also don't worry, I can slow down. Okay, I have 3 questions. One from Trust, one from Arda, one from Dante.
I just wanted, mine says 2 dot equal test by tokens, right there where your cursor's at. And you have EQ. Is it the same thing?
2 EQ?
Yeah, right there. Mine says equal instead of EQ. Is it the same thing?
I guess it is. I should know that, sir. Expect equal. For some reason, I'm used to do the 2 equal. Might have some difference. I would need to research on that.
Yeah, I changed it and it worked.
Okay. Sorry for not knowing that specific difference. I should know that. Trust, you want to go next?
Okay, I wanted to ask in this our testing, what about gas? Aren't we going to consider gas? Or is there
Yeah.
a method that
For now, we're just doing the correct amount of token. We are not doing this other scenario here. We're going to see the gas part. But for now, just using the tokens. I started for this because it's easier, doesn't include gas. We are not going to see the gas in action here. We just pay it and let it go. Okay, for now, we are just seeing if I receive the correct amount of tokens, okay? So when we call this buy tokens, I should pay some massive value to the contract, but also gas too. We're going to see that in a while. Okay, Arda, you have a question too?
Yes, mine is a little bit of the pragmatic side. So because these are tests that we're doing, most probably on the local chain and then the public chain, and that's these tests are never going to be done on the main net. Would it be a good approach to actually add if the ether balances were reflected correctly in this contract? I mean, it would be a longer. I mean, I know this test is not supposed to do that, but it would be a longer test and it would be even more safe.
Yeah, I could
wouldn't
do
it?
this like it stores the correct amount of ETH in the contract. I could do this test scenario too. Okay.
Yeah, no, what I was saying is inside the gives the correct amount of tokens test. Once we so we're checking for if the correct ratio of tokens is rewarded. But we could also add if the correct ether was transferred also. And because this is
Yes.
a test, it wouldn't really matter in terms of the gas. And wouldn't it be just safer? It would be longer to code, but
Yeah, this is why I'm suggesting this new line so that you do this in a separate test. That would be very cool. We would have that test if the contract, after I send this ETH, if the contract is storing that correctly. That would be, it's not very good to mix a lot of tests in the same scenario. It's always good to atomize whenever possible to make it as atomic as possible.
okay, so one more question while I'm at
Yeah.
it. So it seems like we're going to be needing this public fixture with mostly in every single test. Could you like in 1 minute go over the before each stuff?
Yeah, the before each is just a hook like this for each. A hook like this that you can make a function to trigger every time that you are starting a test. You would have a function like this. So triggering to do something like a variable that I have here, or I'm going to deploy something to the smart contract. I could even do these transactions here and balance before and after, calculating the difference in the before each and have some global variable here. Okay. All of this structure would take a little while, more than 1 minute to assemble, but it's possible. Okay, you can keep a class, you can do like databases cleanup, so we can do loops in this before each to prepare for doing the tests later. Okay, because of the architecture of hard hat of those fixtures, is very common for us to load the fixture every time, again and again, and repeat that code, because it's doing more than just picking the variables. It's also rewinding the snapshot, and you don't want to reuse the snapshot 2-3 times. So this is something that you do repeat. Okay, it is a code meant to be repeated. Okay, of course, if I run this function, it's not going to pass yet, because most of the code that we need is in to do. But we have the structure here. I expected the difference of 0 to be equal to this difference here. This is the current state of things as we have. So let's implement the smart contract. And this is going to bring us more and more problems until we resolve. Okay. So determine how much to give of tokens to that person. We determined already amount to be paid multiplied by ratio. So this is the solution. Amount being paid, that is the MSG value multiplied by the ratio. Okay. And we should give the correct amount of tokens to that person. Let's see who remembers on Monday's lesson 9. How do we create new tokens? What function we use it in that my token to create new functions, new tokens? What functions did we use to create new tokens?
Underscore mint.
Underscore mint. But the problem is that underscore mint is private, so I can use it in my token. It's internal, actually. I can use it in my token, but I can't use it directly on the token sale. So this is why we have this public mint function. Okay, which has a requirement, I know. But this function is good here. We could do the token contract dot call, and then I would pass the call data and now, which is very difficult to do. Or do you know any easier way to do this call instead of doing the low-level call? Is there anything I could use to help me calling smart contracts?
The interface, maybe.
Yes, we can use the interface. I could import the my token contract from my token the same way that I could import the my NFT contract from my NFT. And instead of using address, I could use the interface of my token and my NFT in those two situations. Yes, I can. Like this. For the compiler, nothing changed, okay, people? It is still an address, okay? Oh, but we're using the type of my token. The compiler is not going to check if that is indeed a smart contract for my token. It's not going to load the bytecode or anything. The compiler, when it's working with the bytecode for that smart contract, is still going to treat this as an address. This is useful for us developers, so that when we have the token contract, instead of doing a low-level call, I can just call the functions by name. For example, I can call mint by passing two addresses to two parameters to it. I would need a parameter of address 2 and a parameter of amount. So what is the address 2 that I want to mint that those tokens for? I could have implemented as a parameter here, correct? But here I can just pick MSG sender, right? And the value we have already calculated. The MSG value multiplied by the ratio. Now's the time that you stop me if this doesn't make sense for you. Raise your hand, ask in the chat. Yes, Ivan, Arda.
So my question is, why does the caller or the sender has the right to call this function if we restricted it to a specific role?
Yeah,
We're
good
going to
question.
see
I was
that.
thinking that too. That it was that function is actually you can only mint if you're an owner, right?
Yeah,
Or have a minter role.
exactly. So I'm going to compile my smart contract. I'm going to call that function here, and we're going to see that we're going to have exactly this problem. And we're going to see a very interesting part of this architecture. So we had a problem. We reverted with the custom error. Access control unauthorized account. This account is missing this row. But the question is, which account is that? Who is missing the minter row?
The sender.
Let me copy this for you. Let's do a debug before we buy tokens. We do a debug here. I told you that this extension would be very useful. So the account 0x9FE46 is missing the row 9F2D. Okay. So the buyer, the other account address is the account address 0x709979. Is that account that is missing the row? It's not, right? Must be someone else.
Oh, is it the token sale contract itself?
Let me see. Token sale contract address. And yes, the token sale is missing the minting row. Just discovered that by debugging. Did not read the documentation or anything. And it's true, people. A contract is calling the other. So token sale should be the minter. So that I cannot mint, but I could make token sale a minter, right? The same way we did on Monday's lesson. We created a minter role. We could do here and give minter role for token sale. That is right. Token sale right now is not a minter, but it could be. We could give minter role for it, right? So how would you suggest for giving minter role for token sale contract?
Well, as a part of the setup in the deploy contract fixture.
Wonderful. You are guiding the lesson. Thank you. So in the deploy contracts in that setup, after I deploy token sale, before I end the execution, I could do something like this. I know that I'm missing this role 9F2 blah 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 blah, right? Let me see if I still have 9F E46 is my address, and this is the role that I'm missing. So this is the minter role. I can even define this as a const here. Const minter. Or in the worst case scenario, could read that from the smart contract. We did that already. This is the minter role that I'm missing, right? So before I proceed, I could do something like this. Const grunt minter role in the payment token contract. Guess I would have that for the NFT later. Grant minter role for the payment token contract transaction equals to awaiting. In the payment token contract, grant role, right, grant role, and then I'm grant the role of minter role to the token sale contract. Then I'm going to await the public client, wait for transaction received by passing the hash of this grant mint roll payment token contract transaction. And when I complete these, copy and paste this for you in the chat. When I complete this, the token sale contract is going to be a minter in the payment token contract, right? So by doing this, when I come here and run this test, it should work now. It works. Because now the token sale contract is minter for the token contract, for the payment token, so that it can store ETH and it can mint these tokens. Okay.
Can you please show the deploy contract just for the second again?
Here. Okay. The variable minter role is the one that you get from the error. If you want, you can get the minter role direct from the contract, like const minter role equals to await payment token contract dot read minter role. You can do it like that if you want. It's not an address, it's a hash. Okay. Then you can declare this minter role like this. It's going to be one extra read, a few milliseconds wasted, so you can just hard code it because it's not going to change. But if you want to make it like very structured now, you could do that. Okay. And this is the role. Arda, you have a question here?
Yes. In the token sale, when we changed the token contract and NFT contract types, I cannot compile now because in the constructor, we're passing token contract, the underscore token contract, and my compiler says the type address is not implicitly convertible to expected type contract my token.
Yeah, see if you have changed both in line 10 and 16. Because if you don't, we would have this problem.
Oh, I see. Okay. There.
Yeah, and actually what you're doing is exactly this. You just do a casting, okay? You just need to converse the external type for it in the ABI. What we're doing is just changing the ABI. Okay, nothing's changing in the bytecode of the contract. It's just changing the ABI here so that we can properly show people how to call this function. But it's not changing what is happening. It's not like this token contract is going to have all of the members of my token on the token sale, something like that. It's just a pointer. Okay, if you know C or Rust or Go, you know those pointers. So this is just a pointer to the address. It's not the actual entire object repeated again. Okay.
Yes.
So to your question, you need to put the both here so you are
yes, I
treating
did.
them with the same headings.
I did. Okay, so it works. One more thing. Where were we defining the minter role? Was it the first in the deploy contract?
Yes, it is in my token.sol. I have this minter role here on the line 8.
Okay, yeah.
And we did that on Monday. And then I'm using that for giving the role. So now that token sale has this role, it can properly mint here.
Okay, thank you.
We have about 25 minutes. Let me demonstrate the same thing happening with the gas stuff that Trust asked a while ago. So it should charge the correct amount of ETH. If I'm paying 1 ETH, I should have a difference of 1 ETH, right? So I'm going to copy everything. And I'm going to change some lines of code. So the token balance before buy transaction I need to actually check for my ETH balance, right? So my ETH balance before buy transaction is going to be asking the public client get balance. Okay. And then account, the address is going to be the other account dot address. Account. So this is going to be the ETH balance before buy transaction. The ETH balance after the buy transaction. Okay, and I'm going to do the ETH before minus the ETH after. Okay, and I expect this difference to be equal to the amount that I'm sending, right? We copy this test scenario for you. Is this correct, people? I'm buying a burger. I pay $10, I get one burger, maybe a sandwich. Yeah, here in SF, the prices are very high. So it's a real example. You pay $10, you get one sandwich. So I should have one sandwich more and $10 less, right? It should be a very simple test. Is this correct? I'm getting the balance before I buy. I'm doing the buy transaction. Then I'm getting my balance before I buy.
With the negative sign, no?
Balance before minus the balance after.
Yes.
Yeah, like I had $100, now I had $90. So the difference should be 10. Okay, let's test. So let's see. Expected this difference, and we have this difference. I can be just a rounding error, right? Such a small difference here, correct?
There's a gas charge.
That is the
Right.
gas charge. I'm paying taxes to the blockchain. Just kidding. I'm paying for the transaction because it's payable, and I'm also paying for the block space because it's also payable. It's incentivized by the blockchain. Remember lesson 1? So here we need to account for both. So difference would be equal to this minus the gas costs. 0n for now. But I could pick the gas costs here, okay? Because we are in a haste, I'm just going to do the solution. The gas cost can be picked from the receipt. Const receipt can be like this. And I can get the gas amount. Amount. That would be the receipt. Gas used. Cumulative gas used, the total amount of gas that was used, okay? And I can get the gas price. That is the receipt dot average effective gas price, actually not average gas price, effective gas price. The amount of gas that I used in that transaction and the gas price that I paid per gas. So the gas cost is just the gas amount multiplied by the gas price. Okay. So if I account for gas, let me see if I did it correctly. This test should work now. It's passing. Okay. So you would do something like this. We copy the whole test. So this would be the test so that it's charging the correct amount of ETH. Okay. Trust, you asked about this earlier. So when charging the correct amount of ETH, I'm charging if it I'm checking if it is charging the value to buy tokens plus the gas cost for that transaction. Okay, I need to account for both. Good. Ivan, you have a question? I see you have an open mic there. Yes, Javier, have a question?
Yeah, I saw a method for the receipt that says gas used. What's the difference between cumulative gas and gas used?
Cumulative gas usage, it is actually, this is the correct one. You are correct, Javier. The gas usage. Cumulative is wrong. This one is the correct, actually. Just notes it,
But
Mayo.
and the
Cumulative
other
gas
one,
usage.
what means?
Cumulative gas usage is for all the transactions up to that the gas usage to all the transactions up to that transaction, that block. Here, since we just have one transaction, the block is blocked. But you are correct. The gas usage is the correct one for us to use here. Okay. Good. So this is the correct one. Thanks for asking. Ivan, the TokenSale.sol. So basically we have the same thing we had yesterday, just changed the interfaces here, imported and changed the interfaces. And now we have this buy token function with one line of code, okay? Any questions here? Anything different?
My tests give an error of type error cannot convert undefined to a big int in the beginning. What am I missing?
Maybe you forgot to compile your contracts.
I did, but maybe I wrote something wrong. Okay, could you show me the token sale token contract.mint?
Token sale.
Yeah, token sale.
Token contract.mint here. We are picking that from the my token contract that we used on Monday. Okay.
Yeah. Okay, I'll figure it out. Thank you.
Yeah. What is the test that is giving you this error?
Both of the tests that we did that charges the correct amount and they give the correct amount of tokens. Both of them say the same thing in the beginning.
In the beginning.
Yeah, in the it's line.
Like this?
No, even above in the line that starts with the it. Yes, 69.
Okay. Maybe it's something about your describe. Maybe you forgot to finish a semicolon.
I was getting an error with the async on the describe block. Is that something that you're getting, Arda?
Yeah, I mean it's showing the async line, for example, where you're seeing 69 here. So I think I'm missing something up here, but could you show the top of the token sale TS?
The top here is those consts, and then we have this deploy contract.
Yeah, so we don't need the minter role in the line 6 anymore, right?
You can have it hard coded here in the line 6, or you can get it on the fly inside the deploy contract. Okay, but at this point, we have like 10 minutes, 15 minutes to finish the lesson. Maybe you want to just sit back, relax, follow the last
I'll work
15
on it.
minutes, and then you can pick on that on
And
the
then
report.
if not,
Don't worry. Yeah. I've been there, people, and I have done this lesson, I guess 50 times or so, 60 times maybe. So it can get stressing, like, oh, I'm not following, I'm not coding along. So don't worry at all. The most important thing here is not to complete the token sale. The most important thing here is for you to pick up the process. Okay, when you are going to deploy your own smart contract, so think on the cases first, or write the test, or write it somewhere, so you can discover the things. Oh, I need Minter. How do I give the Minter role? Oh, I need to deploy it. I need to do an external call. I need to inherit from this. So the important thing is the chain of thought, which we are having, right? You are suggesting next changes, and also this is the important part of this lesson. Completing token sales is a mere exercise. Important is that we have the process in mind. Okay. I'm going to do one of these two scenarios in the next 10 minutes or so to exemplify about ERC20 transactions, because they are a bit different from normal ETH transactions. For example, when a user burns an ERC20 at the shop contract, when the token sale here, when someone calls this burn tokens, and the transaction is going to be a bit different. Okay, let's discover that. It's going to be maybe the last exercise for this challenge. How would you implement this burn tokens function based on what we did from the buy tokens? Just the function description.
Well, again, we're going to have to make it accessible and opening it up to getting paid, or moving value.
Okay, public external. Okay, let's go with public. External would do. It needs to move value. Yes. Does it need to move? Does it need to receive network tokens? For example, I can put as payable, so it can receive the network tokens here. Okay. Is this function going to receive network tokens like ETH?
It's not going to receive ETH, but it's going to receive a token.
Yes, it's going to receive a token, but how she specified my payable that I need to pass a token as this token contract address? Is there anything like this in Ethereum? Unfortunately, there is not. Okay. ETH is the only token that you can deal in smart contracts with the payable function. There is no payable address for other functions. So
Okay, so you wouldn't need it. All right.
it wouldn't need it. But now I need to pass the amount because I don't have it in the MSTG value anymore. I will need to have a UINT 256 amount. Okay. And now the amount of tokens to be burned. Tokens to be burned is this amount of tokens that I'm going to burn. And what is the amount of ETH to be given? How much ETH?
Half of the equivalent of the that
Not
he
half
sent.
yet. This would be for the NFT. We are not going to have time to get there. It would be nice to evaluate the price and more. Here it is this scenario yet. Withdraw ETH by burning ERC20 tokens at the contract. So if the ratio is 10 and I send one token to be burned, I'm going to get 0.1 ETH back, right? I paid 1 ETH for 10 tokens, right? So it's going to be the amount divided by ratio. What if the ratio is 3? What if with 1 ETH I buy 3 tokens, and now I want to return 1 token?
So this is the exact issue with the decimals, right?
Exact issue with the decimals. So ratios are not a very good idea. Using decimals, it can solve a bit of this problem by burying this problem with a lot of zeros until it becomes insignificant. But the problem is that sometimes these little amounts, for example, let's use this mental exercise. I buy 3 tokens with 1 ETH. Okay, so I had 10 ETH, now I have 9 ETH. And now I have 3 tokens. And then I return 1 token. Now I have 9.3, 33333. And then I return 1 more token. Then I have 9.66666. Then I return 1 more token. Then I'm going to have 9.99999. Disregard the gas fees. Where went that one way? This one way is going to be stored inside this contract forever. And this could cause problems. Eventually, it could even mess up like liquidity pools or something like that. So divisions are very dangerous with smart contracts. If you have the time, do the things with price, because converting from ratio to price, you can eliminate the divisions. Everything is going to be addition, subtractions, and multiplications, which are much more safe. But here we can use the ratio just to show the problem. And then when you do the exercise at home with the NFT, you can experiment with the price. Okay.
The fact that you mentioned that the division is dangerous, are you saying that to be aware of that when we're doing this kind of stuff and try to navigate in a way where you're not doing as much division or taking a lot of consideration when you're doing it?
Exactly. Or even remove divisions at all. For example, in this situation, instead of using ratio, I could use a price per token. And every time I burn tokens, I'm going to give ETH back the amount multiplied by the price. And if I wanted to subtract that, it's going to be minus the amount multiplied by price. Okay. Here with buying the NFTs would be clear. We're going to do something similar in the future with a lottery where we bet, and we bet a lot of times. Here, if we buy NFTs a lot of times, if I buy 3 NFTs, I'm going to pay 3 multiplied by P. If I burn 3 NFTs, it's going to give me 3 multiplied by P divided by 2. So long it's all even, it's good.
Yeah, because like I remember like when you were minting NFTs back in the NFT boom, that the price was fixed when you minted, right? And that's
Yes,
what I'm talking about. Your P is going to be fixed in the contract, and so it can't change.
yes, and you know what is the result of this division or subtraction when you're operating with it. With the ratio, you never know. If the ratio is 17, for example, you're going to have a lot of weird numbers, and then you can lose those by truncation. Okay. In the worst case scenario, imagine that the ratio is 10, and I'm going to burn 9 decimals of these tokens. I'm going to burn 9 away, for example. How much I'm going to receive back? 9 divided by 10 for solidity, how much it is? 0. I'm going to receive 0 back. This can come to attacks and errors. Okay. Let me implement that real quickly because it's going to need one structural change. In my token, I would need to import from the extensions of the ERC20 this feature of the ERC20 burnable. Yes, it's possible. Instead of importing it from here, there is this folder called extensions. Just like this. And that is the ERC20 burnable token. Extensions. Not this one. ERC20 burnable. .sol. Let me get that from node models, the quickest way to find it there. Open Zeppelin, token, ERC20, extensions, ERC20 burnable. I did the hard part, I just forgot the C. Sorry about this. Okay. What the hurry does for us. So by marking this ERC20 as ERC20 burnable, let me copy this for you. Just here in the chat. I'm going to get one function, one inherited function here from ERC20 burnable. That is, I clicked the wrong contract. Sorry about that. ERC20 burnable. That is burn and burn from. This burn and burn from functions would remove those tokens from circulation. And burn from is a similar structure as transfer from, that I would consume this amount of allowance. I would allow people to spend my token first, and then I would consume this allowance when calling this token, when calling this function on this token. Let me show that for you. I'm afraid I have 2 minutes for that. It's going to be hasty. So in the TokenSale.sol, I'm going to have a function that is going to pick the token contract and is going to burn from the MSG sender this amount that I'm passing, and is going to transfer to the MSG sender the amount divided by ratio. Using compiler here to sheet because I'm out of time. Okay. So this would be the function burn tokens. I'm burning from the MSG sender this amount. For it to work, I need to have approval first. Let me show that for you in the test. So when the user burns the correct, when the user burns, should burn the correct amount of tokens. So I'm going to copy the whole test for buying the tokens. Okay. So the token balance after buy transaction is going to be this. Okay, well, we need to repeat because I cannot burn if I don't have those tokens. And then I can try and burn tokens and have the transaction received. Let me compile my project first. But this is going to give me problems because I didn't approve how the contract is going to burn my tokens if I haven't approved it yet. Burn tokens, burn tokens. The syntax here is incorrect. Sorry about that. Now it's correct. So this is going to give me one problem. Let me test this here for showing the problem. It's going to say, I don't have enough allowance. I did not allow anyone else to expend my money. And this is a good error. Insufficient allowance. Someone is trying to burn these tokens from me and I didn't allow it first. So this is how you pay with ERC20s, people. You don't send a payable transaction for a contract. Actually, what you do is to allow first, I'm going to do this allow transaction const approve transaction. I would await the payment token contract, writing this approval function to approve the token sale contract for this balance using this account. Compiler got it correct. I would await the approval transaction, and when I have this approval completed, then I can burn the tokens. Okay, I cannot send ERC20 tokens directly for the smart contract. No, the only thing that I can do is to tell the smart contract, hey, you can spend my tokens. Here are my tokens. You can spend by doing this approve transaction. And then when I call this burn tokens functions, this is going to pass because now I have this allowance. I have allowed the contract to spend money on my behalf, to transfer money or to burn these tokens. Okay. Then here I would need to do the math. I would need to expect it correctly. So I would expect the difference. Let me see if Copilot can do it correctly. Expecting the token balance after burn to be equal to 0n. Maybe that's correct. Okay. Sorry for the hasty implementation with AI here. I'm going to copy this test scenario for you. And sorry for the extra minutes if you have to go. Sorry about that. You can pick this less minutes from the recording. So this would be the way for us to transact ERC20s to contracts. Instead of doing the payable doesn't work with ERC20s, I would need to approve it first. So for the future tests, if you want to buy tokens, you would need to approve the ERC20 for sending to buy these tokens. Then you would mint to this ERC721. When burning the ERC721, you would need to approve the NFT to be burned. That is all of this structure here for doing the finances, financial accountings of ERC20s, okay, on your contract. And that concludes for today. If you want to complete this testing, you don't need to do that by tomorrow. Tomorrow we are going to do another smart contract tokenized ballot. So if you want to complete it at home with time later, feel free to ping me with the issues, with any kind of problems that you might be facing on GitHub issues, on Discord, or anywhere that you find it better for us to collaborate. And this is going to guide you on implementing all of these patterns and solving all of those issues that we have here. Okay. I'm going to pick a few questions, but we are above the lesson time already. If you need to leave, please don't worry. You can leave. Yes, Dante.
Thank you. One real quick, for the debugging, I'm not getting it to work. So is there any reference that you can paste in the chat for me to figure out the debugging and the testing for visual Cursor or Visual Studio Code?
Yeah, Cursor VS Code should work the same. Is that extension called Mocha Test Explorer from lesson 5? This one here. Mocha Test Explorer, remember? Okay, then you should have this extension for it to work.
I have it, but it's not working. I don't know what's going on.
Yeah, there are some issues about this in the repository if you want to search. If not, you can open an issue there. I can try and troubleshoot. Okay. So let's me, Ivan. Now for the code, the TokenSale.sol is here. So we did those two functions today that I'm going to send for you in the chat. Okay, please save it there. It is something that you should be able to code by yourself with watching the recording too. And the TokenSale.ts, it is except for the last scenario that we did with the ERC20, except for this, everything else that we did is the normal flow of conclusions for today's lesson. So it's part of the exercise. Okay. If you want, I can send you this. That would burn it would expect. So that would be the AI generated code that I have. You can do that yourself on your side with time. Okay, so you would have the same results if everything is correct. Okay, pasted here in the chat. The token, my token.sol is burnable. I've sent a while ago. It's just the import and then add it here. You should find it there. That's it, people. I have to go to, but thank you, everyone. Thanks for those extra 5 minutes too. We talk again tomorrow for another smart contract using tokens called the tokenized ballot. Thank you. Bye-bye.